What if motion had a currency? In physics, energy is the account that keeps track of every change. Energy is not a substance hiding inside objects. It is a measurable capacity to cause change. When a force transfers energy by moving an object through a distance, physicists call that transfer work. For a constant force in the direction of motion, work equals force multiplied by distance. W equals F times d. Direction matters. A force at an angle transfers less energy forward, so the general formula is W equals Fd cosine theta. Hold a heavy suitcase still, and your muscles may work hard, but the suitcase receives zero mechanical work because it does not move. Kinetic energy is the energy of motion. For an object of mass m moving at speed v, it is 1/2 mv squared. That squared speed is important. Double the speed, and kinetic energy becomes 4 times larger if mass stays the same. Potential energy is stored because of position or configuration. Near Earth, lifting an object gives it gravitational potential energy. Near Earth's surface, gravitational potential energy is mgh. Mass times gravitational field strength times height above a chosen reference level. At the top of a roller coaster, gravitational potential energy is high. As the car descends, that energy becomes kinetic energy. In an ideal track with no friction, the total mechanical energy stays constant. Kinetic plus potential energy remains the same. Real coasters are not ideal. Friction and air drag transfer some mechanical energy into thermal energy and sound. Energy itself is not destroyed. It moves between forms and systems, although some forms are harder to use for organized motion. A pendulum makes the trade visible. At the highest points, gravitational potential peaks. At the bottom, speed and kinetic energy peak. With air resistance and friction, each swing reaches a little less height, because mechanical energy transfers into the surroundings. A spring stores elastic potential energy when compressed or stretched. For an ideal spring, that energy is 1/2 kx squared. Release the spring, and elastic energy becomes kinetic energy. A stiffer spring or larger displacement stores more energy. The work-energy theorem connects force and motion. The net work done on an object equals its change in kinetic energy. To solve an energy problem, define the system, choose a reference level, list initial and final energies, then include transfers like friction. Imagine a 1 kilogram object raised 2 meters near Earth, using g approximately 9.8 meters per second squared. Its gravitational potential energy relative to the floor is mgh, 1 times 9.8 times 2, or 19.6 joules. If it falls without air resistance, that 19.6 joules becomes kinetic energy just before impact, so 1/2 mv squared equals 19.6. Work transfers energy, energy changes form, and conservation lets us predict motion. Once you track the account, mechanics becomes much clearer.